the data centers, right? So they want to ensure the reliability and they want to ensure the confidentiality and storage of your data secure. For example, if you see, you know that Amazon is a very popular website for shopping. Amazon has a number of data centers in the United States, one on the East Coast and another on the West Coast and the Europe. You know that Amazon is a big company and they have established their data centers across different locations. However, however, the Amazon is expecting its cloud customers to express a preference where they want their application services to be hosted. So, Amazon is asking its cloud customers where they would like to have their cloud services. They want to have in India, they want to have at some other location in the world. But the main problem is that Amazon does not provide any automatic mechanism for scaling its hosted services across different geographical distributed data centers. So even though the Amazon has different data centers at different locations, but the Amazon does not have a mechanism through which all these data centers at different locations they can cooperate together and they can provide a mechanism, automatic mechanism to scale different hosted services at different locations. So sometime when the customer is expecting more number of resources at some location, the resources will not be provided by the data center because of its limitation. And other data centers which are there at different geographical location, they are not able to automatically provide the requested resources to the consumers because it does not have a automatic mechanism. Manually, it is possible that another data center may be deputed to provide more number of resources to the customers, but Amazon does not have an automatic mechanism to scale or increase or decrease the requested resources for the hosted services. Right. So that is the big problem. You see that that is the big problem here in case of Amazon. So what is the solution? There should be some automatic mechanism which can provide the requested resources and which is able to scale in and scale out all the requested resources for all the services which are hosted by the Amazon at different geographical locations. So you see one diagram, cloud loading results at 4 gateways at resource sites in the grid 5000 system. This grid 5000 system, this was actually developed by Melbourne University. Okay, and this was suggesting a number of ways how the resources in this cloud environment can be exchanged among different cloud service providers. So you see that there are 4 gateways which are actually there to provide different cloud services to the consumers. Nancy, Rances, or say Sophia, and you see these terms. You see the different colors used for different kind of things like load without peering. Okay, you see the load without peering. You know the load may vary between 0 to 100%, and it may vary more than that. Load when peering, load without peering means the system is not cooperating with other systems. Okay, load when peering, it means the computer system they are actually cooperating with other systems and they are providing some set of resources to other for other services. Load accepted. What is the amount of load that is acceptable by that gateway, and what is the load redirected? Load redirected means if the uh, gateway does not uh, gateway is not able to handle all the load, then it will shift this load to other gateway. Okay, and that is basically highlighted by this term load redirect. Okay, so you see in case of this Nancy, okay, load without pairing, load when pairing, okay, load accepted and load redirect. If you see this RENAS, okay, so load without pairing is quite high, 1.8. Load when pairing is around 1.0, it means it is fully loaded. The load is varying from 0 to 1. It means that it is from 0 to 100%. If it is more than 1, it means that it is more than 100%. Right? So, you see load redirected is also very high because it is going to be fully utilized. Okay, in the same way you can see in case of Force, you see the load is very low. Okay, and the amount of load that is being redirected is very. Okay, so more the gateway will be utilized, more will be the utilization of the gateway, more will be the chances that it would be redirecting the load to other gateways. Right. So you know that if some gateway which is providing services to large number of consumers, cloud consumers, and if it is going to be 100% utilized, then obviously it cannot handle more than 100%. Right. In that case, if it is still having some other load, then this load will be redirected to some other gateway that is actually going to be underutilized. Okay, so we have seen the example. So we have seen the example of Amazon, and we know that Amazon does not provide any automatic mechanism through which the resources of different cloud service providers can be exchanged. Right. So this approach has a number of shortcomings. First, uh, it will be difficult for cloud customers to determine in advance the best location. Amazon is asking its cloud customers to tell where they would like to get their services. So the cloud customers they would not be knowing what is the best location to host the services. Okay, and as they may not know the origin of the consumers of their services. So what happens? Amazon is basically the service provider, and cloud customer is some other company which is actually taking some services or resources from the Amazon, and that company is actually providing services to other users. Right. So you know that in case of cloud environment, these different consumers will be from different locations. Okay, because they are actually accessing all these services in the online mode. So it will be difficult for the cloud customers to determine the location, best location, which they would like to have to use their services, because their consumers are distributed across different geographical locations. The second problem is that SaaS providers, SaaS providers means software as a service. The cloud service providers who are actually providing software as a service, they will not be able to meet all the quality of service expectations of their service consumers. Right. So you know that quality of service parameters are there on the basis of which the consumers, cloud consumers, they are actually judging your services. So quality of service parameters include like how much time it is taking your system to respond, and uh, how quickly your system can perform the task. Okay, and reliability and other issues. So there could be different quality of service parameters which may be specified for different cloud service consumers for different kind of services, right? So software as a service providers sometimes will not be able to meet all the expectations of their service consumers, okay, which are from different geographical locations. Okay, so these two problems actually specify a need to specify new mechanism, okay, so that the exchange of cloud resources among different cloud service providers can be done dynamically. So this necessitates building mechanisms for which data centers of a cloud service provider may support dynamic scaling of applications across different domains so that quality of service parameters they can be met out by different cloud service providers. Okay, so if the cloud service providers they should have some automatic mechanism so that they may provide some necessary resources to other cloud service provider in case of any demand is there. And for that purpose, they have some agreement. They have some service level agreement with other cloud service providers. So this Melbourne group has proposed a inter-cloud architecture. How this exchange of cloud resources among different cloud service providers happen in real time. So you see this diagram. So in this diagram, okay, you see there are different brokers. Broker 1, broker 2, broker N. Okay, and you know that this is the cloud. This is the cloud, and different cloud service providers, infrastructure, and other resources are attached into this cloud. Okay, so this is the compute cloud, this is infrastructure cloud, this is the storage cloud. This could be the another compute cloud of another service provider. This could be the another storage cloud of another service providers. So all these service providers are basically connected to this overall large cloud, right? And all these, they are actually publishing their offers, okay? And these offers, they can be utilized by other service providers in case they demand for resources, right? And there is a one more thing that is known as the enterprise resource manager. Enterprise resource manager. So this enterprise resource manager, okay, is requesting for some resources of a particular capacity to the broker. And this broker, depending upon the requirement, it will negotiate with other cloud service providers which can provide these necessary resources of the given capacity. Right. So different service providers they are having different kind of uh, uh, storage cloud, different kind of compute cloud, and other clouds. And these brokers are there who are actually negotiating with different service providers so that they can get the necessary resources which are requested by this enterprise resource manager. And you know that enterprise resource manager is requesting for the resources on behalf of a cloud service provider. Right. So this is actually known as the brokerage model. Okay. You see that inter-cloud exchange of cloud resources through brokering. This is actually happening through the brokerage model. And there is another limitation. You know that once cloud service provider will not be able to establish its data center at all the different locations where it is providing the services. You know that for no single company, it is possible that they can establish their data centers at all the locations across the world. Okay, so definitely when at a particular location they do not have the data center, they have to utilize the resources of some other company who are having data center into that location. Okay, okay. So what happens? These different cloud service providers, because of this limitation, they make use of services of other cloud service providers who can provide support and who can satisfy the customer demands. Okay, and you know that the same thing is happening in case of the mobile services or the telecom services. Okay, so this kind of requirement arises in some global enterprise, okay, and which can perform global operations across all the different cloud service providers using the internet services, using the web 2.0 applications. Okay, it means that one cloud service provider will have different data centers at different locations. Okay, and these cloud service providers at different locations will have an agreement with other cloud service provider so that it may provide the resources automatically to other service providers. Okay, so we have seen this model which was proposed by Melbourne University, that is actually known as the Cloud Plus project, and they have proposed a inter-cloud architecture which is able to support the automatic uh, provisioning of resources to other cloud service provider, right? And this is actually known as the brokerage model. It is actually supporting the brokering and exchange of cloud services so that the scaling of cloud resources can happen across the different cloud service providers. So once this architecture is there to provide automatic exchange of resources among different cloud service provider, what it will offer. In that case, if it is there, different cloud service providers, they will be dynamically able to expand and resize their resources depending upon the consumer demands, depending upon the workload. Okay, they can get any type of resource, whether it could be a compute resource or a storage resource or a platform resource or a virtual machine resource. They will be having a large pool of resources available with the help of other cloud service providers. And that's why it is possible to provide services to large number of users across different geographical locations. They can operate as a part of a market-driven resource leasing federation. Okay, so you might have heard about this site Salesforce.com. Salesforce.com. It is actually providing cloud services. It is actually providing application cloud services. Okay, and different companies they can negotiate with this Salesforce.com to host their services using the application services provided by this company Salesforce.com. Right. So this is actually going to be a market-driven strategy. So in the market, you see the different cloud service providers are there. They are having their own infrastructure. They are having their own data centers at different locations, and they are offering their resources on rental basis or some agreement basis to other cloud service providers. Okay, so this market, this kind of philosophy is driven by this competitive market prices. This architecture can deliver on-demand, reliable, cost-effective, and quality of service-aware services based on the virtualization. And simultaneously, it will reduce the cost. It will reduce the cost of resources which are supposed to be managed by a cloud service provider. Because the cloud service provider now does not require to establish their data centers across all the locations where they are providing services. Right. And they will be utilizing market-based utility models for provisioning of virtualized software services and other hardware infrastructures. Okay, among users who are using different heterogeneous applications. Heterogeneous application means different variety of applications. You know that the consumers would be using different kind of applications. They would be having demand for different kind of hardware resources and software resources. Okay, so this actually is based on the utility model. Okay, this market is actually based on the utility model. Depending upon the utility, the price it needs to be paid by the consumer. Okay, so this architecture consists of client brokering. You have seen that there are various brokers. Okay, and there is one coordinator service. Okay, so this coordinator service is actually having request of resources from different cloud service providers, and all these requests they will be scheduled. All these requests for different kind of resources they will be scheduled, and the necessary resources will be allocated from different cloud service providers using this brokering. Okay, and sometime when some data center is heavily loaded, it will transfer the load, it will transfer the workload from one data center to another data center automatically. So application scheduling, resource allocation, and migration of workloads, this is actually done with the help of these coordinator services, which are talking to the different brokers to access all the resources. Okay, so in this way, this architecture is basically combining administratively and topologically distributed storage and compute capabilities of cloud as a single resource. So what happens in such an architecture, to each and every cloud service provider, all the resources exist as a very large pool. All the resources which are viewed on behalf of a cloud service provider, they appear as a single resource. Right. And depending upon the demand, depending upon the changing workload, they can access the requested resources from different cloud service providers. Okay, so this architecture will ease the cross-domain capability integration for on-demand, flexible, energy-efficient, reliable access to the infrastructure based on virtualization. Okay, so what is this cloud exchange? You see that what is this cloud exchange? Okay, So in this figure, you see these dotted lines. So this is basically happening. This is actually acting as a cloud exchange. This is actually acting as a cloud exchange. So this cloud exchange is going to act as a market, which is actually bringing different cloud service providers and different consumers. And it is basically the aggregation of all the demands. Okay, different brokers, they are actually getting the resources from this cloud exchange. Okay, and this is actually cloud exchange is aggregating or summing up all the infrastructure demands from different brokers, and it will evaluate what is the supply, what is the current available set of resources, right? So different cloud service providers, they will publish their resources to this cloud exchange, and different brokers, when they require the resources, they will send a request to this cloud exchange. So this cloud exchange will see what are the different requests which are coming from different brokers, and it will see what is the currently allocated resources of different cloud service providers. So this is actually supporting trading of cloud services based on the economic model. So like you know what is happening in case of the stock market, there are different companies you can buy and you can sell different shares into the stock market. So same thing happens. This cloud exchange is acting as a market for different cloud service providers in which they publish their resources they have, and this cloud exchange is there to exchange of resources among different cloud service providers using the brokers, using the concept of brokerage. Okay, so this cloud exchange, it allows the different participants into this cloud to locate different service providers and consumers. So different cloud service providers, they have different kind of offers. So like in share market, you see, stock market, you see there are different kind of offers. So same thing happens here. Okay. So what is the commodity? In case of stock market, you see that share is the commodity, that is the thing that is being transacted on. In this cloud exchange market, your services are going to be the commodity. So it is happening to be a dynamic market, and different cloud service providers, they have different SLAs with different cloud service providers. How this exchange of resources will happen. So SLA will specify detail of the service to be provided in terms of metric. Okay, there will be some metric that will specify uh, uh, what will be the conditions for the service, what will be the quality of the service that will be provided by one cloud service provider to another service provider, and it will also list out some incentives and penalties if the cloud service provider does not meet out all the requirements, or cloud service provider is violating some set of conditions listed into the SLA. Okay, and there also exists a banking system into this cloud exchange market. Okay, which is there to store all the different financial transactions. Okay, which are related to the SLAs among different cloud service providers. Right. So this is all about this inter-cloud exchange of resources.